Hi, I'm Dr. Sarah from the Medical Mojo team, and today I'm talking about the story of Nystatin. This story weirdly has similarities with this book, The Alchemist, but before we go any further, there will be spoilers, so if you haven't read the book or are halfway through, stop the video, go read it, and then come back and continue your viewing. If you have read the book, or if you're not too fussed, carry on watching this video. So, The Alchemist is the story of a young boy's search for treasure. This is the fabled cursed treasure of Cortez himself, no less. Now, Nystatin is not made of cursed gold, or any gold for that matter, but the relevance of the book will become clear in a minute. Nystatin is an antifungal, and much like other antimicrobials, it's actually bacterial in origin. So in the natural environment, fungi and bacteria live cheek by jowl, and they are constantly competing for natural resources. In the true spirit of survival of the fittest, they develop chemical weapons to basically annihilate each other so they can keep all those resources to themselves. Who would have thought that infinitesimally small microscopic organisms share our propensity for greed? Anyway, we humans exploit this. We purify these chemical weapons to produce antifungals and antibacterials. So let's get back to the story of the discovery of Nystatin. It's actually a long forgotten story of the work of two scientists. After the serendipitous discovery of penicillin by Professor Alexander Fleming, doctors treating wounded soldiers during the World Wars noticed that they had actually improved recovery rates from bacterial infections, but they were still succumbing to fungal infections caused by organisms such as Candida albicans and Cryptococcus neoformans, which are fungi. This led to Elizabeth Hazen being tasked by the Division of Laboratories and Research at the New York State Department of Health to find an antifungal drug. So she set up a lab and she received soil samples from exotic locations around the world, just like the young boy Santiago in The Alchemist, who searched the world looking for lost treasure. Elizabeth Hazen then went about analysing these soil samples, and any that showed promise would be sent to her colleague Rachel Brown, who was a chemist in Albany, New York State. It was Rachel's job to then purify that sample, create an antifungal drug, and send it back to Elizabeth so that she could test it. The dynamic duo tested thousands of samples, and yes, they did find some that could actually kill the fungi, but they were also found to be very toxic and therefore not appropriate for use in humans or animals. But after a few years, they hit the jackpot. They found a drug that not only killed the fungi, but was also safe to use in animals and humans. And where did they find that microorganism that created that particular chemical weapon? After searching all over the world, it was from a soil sample taken from the garden of one of Elizabeth Hazen's friend, Jessie Norse. And to honour the discovery, she named the bacteria after Jessie, Streptomyces norsei. And I think the moral of that part of the story is be nice to scientists. And who knows, they may name a bacteria after you. Elizabeth Hazen and Rachel Brown then presented their findings in 1950 in the New York meeting at the National Academy of Sciences. This attracted the attention of Big Pharma, and consequently the women became rich and famous. But to their credit, they reinvested a lot of their money in a non-profit organisation to continue their research. They named the drug Nystatin after the New York State Department of Health, which explains the NY at the start of Nystatin. So, much like the young boy Santiago in The Alchemist, who searched the whole world for treasure only to find it at home, Elizabeth Hazen and Rachel Brown found their own pot of gold in their friend's backyard. So there really is no place like home. Nystatin is still widely used today, usually to treat oral thrush or oral candidiasis. In 2021, 573,043 prescriptions were dispensed in the UK at a cost of £1,149,462.74.